Hi everyone and welcome. I'm Gavin Lon. In this part of the course, we're going to look at variables and data types in Python. So by the end of this part of the course, you'll have an understanding of the basics of variables and data types in Python. If you haven't yet seen the first part of the course where we set up our local machines to develop applications using Python and also create our first basic Python apps, please check out the Introduction to Python part of the course at this URL. The link has been included in the description of the video, or please click on the card presented in the top right-hand corner of your screens. So we've already touched on variables in the previous section of this Python for Beginners course. Basically, a variable can be defined as a reusable container for a value. In the previous part of the course, we installed Visual Studio Code. So let's fire up Visual Studio Code. I'm just going to open the folder for the Python code example that we created in the previous part of this course, and then just select that folder. In the previous part of the course, we created a basic app that firstly prompts the user for the user's name. Once the user enters the user's name and presses the enter key, an output is presented to the user, which includes the literal text hello, and then whatever text value the user entered at the prompt. So in the first line of code, a variable named uname was assigned the value entered by the user at the command prompt. The uname variable was assigned through the equals operator, whatever is returned from the built-in Python input method. The input method denotes the prompt functionality that pauses the program and prompts the user for the user's name. Once the user enters the user's name and subsequently presses the enter key, the entered text is assigned to a space in computer memory, denoted by the uname variable in code. So a variable in Python can be described as a named reference to a value stored in memory. The variable is created using an assignment statement, in this case uname equals input, and then we have a prompt, please enter your name, passed as a literal string to the built-in Python input method, like this. So the Python built-in input method returns whatever the user enters at the prompt as a string data type, which is then stored in a portion of memory. In code, this is referenced by the variable name uname. The input method returns a value of a string data type, so it is important to note that this is how variable types are determined in Python. In this case, whatever the user enters, so let's run the code quickly. So to run the code, we go py main.py. I hope you remember this from the previous part of the course. Press the enter key. We enter our name, Gavin. When we press the enter key, the string value of Gavin will be returned by the input method and assigned to the uname variable. So let's press the enter key. Hello followed by the string value of Gavin is outputted to the console screen like this. And you can see that we discussed this briefly in the previous section of the course, that this is what's known as an F string, which basically allows us to include a variable value within a string literal like this. So the rules of the F string is that the variable name must be wrapped in curly braces within the string literal, and the string literal must be preceded by the lowercase f character like this. In Python, the data type is determined by the type of the value assigned to the variable. This is different to how data types are determined for variables in statically typed languages like C#, Java, or C++. In these languages, the data types are explicitly declared before values are assigned to them. To show you the difference in how data types are determined in a strongly typed language like C#, I'm quickly going to set up a .NET Console project within another instance of Visual Studio Code. So let's minimize this instance of Visual Studio Code. Let's open another instance of Visual Studio Code, and I've prepared this folder here so that I can create a .NET Console app within it and just demonstrate how data types are created in C#. So to create our .NET Console app, we type .NET new followed by console like this. Press the enter key, and it will generate the infrastructure for our C# project. I'm going to clear the screen there. Great, and if we open that there, we've got now all the files that have been generated for us for a console, for a .NET console application. Let's double click on the program.cs file. We can just give that a quick test by typing .NET run at the command prompt and press the enter key. And it's worked. Hello world is presented to us on the console screen. So let's clear the screen. Please don't feel like you need to follow along with the C# example. I think it's best to follow along with just the Python examples. This is, of course, a Python course, and I don't want to muddy the waters, as it were. So in C#, this is how a string variable named A would be declared. So you would type string, which is the data type, followed by the variable name, which in this case, we're just going to call it A, like that. So we've declared string variable A in C#. So the variable's type is determined at compile time. .NET knows that variable A is a string at compile time because we've declared it explicitly with the string data type in code. This means that the variable types are known before the relevant code is deployed and run. In Python, which is a dynamically typed language, the data type is determined dynamically at runtime by the actual value that is assigned to the variable. In C#, you can't, for example, declare a specific variable. Let's say our variable is named uname, like this. And then let's assign uname the string value of Bob, like that. And let's we'll write that to the console screen, uname, like that. Let's just test that. Let's run that code by typing .NET run, like that. Great, so Bob is printed to the console screen, so that has worked. But now, what happens if we reassign uname to what's clearly an integer value? So 1040, like this. Well, it's actually already flagged an error at compile time here. Cannot implicitly convert type int to string. So you won't be able to build this particular program. So now if we try to run this code, so .NET is going to try to compile our code, but as you can see here, there's a type mismatch, and C# is a statically typed language, so it should flag an exception. And there you go. Cannot implicitly convert type int to string. The build failed. Fix the build errors. So you can fix your data type related errors at compile time with C#. And this is one of the advantages of a statically typed language. So this minimizes the chance of you getting type-related errors at runtime because those type mismatches are fixed at compile time before you even build your application and deploy them into a production environment. So that clearly hasn't worked. Whereas now, if we go back to Python code, so let's go to our code here. I'm just going to comment these out using a hash symbol or pound symbol if you like. I'm just going to comment this code out here, and let's try to do the same thing. So let's first create a variable named uname and assign it to a string literal of Bob. Let's use the print inbuilt Python method to output whatever is stored in uname, in this case the literal string Bob. Oops, look at me. I'm terminating each line with a semicolon. Of course, you don't use a semicolon in Python. So anyway, let's see what happens now. So if we type py main.py like this, press the enter key, Bob is outputted to the console screen, which is correct. And the other thing about Python, now if you subsequently assigned a numeric value, let's say a whole number value, 1040, and then try to run the code, that is also valid. So Python doesn't mind if you change the type for a particular variable later on in code. So uname was firstly a string, and then it became an integer with no hassles. Python is a dynamically typed language, so it's interpreted line by line in Python, so you can get away with this in Python. And in C#, you have to declare your variables as a specific type, so you can't subsequently change its type to another value like this. And that's the difference between a statically typed language and a dynamically typed language. Let's briefly discuss what the Python interpreter is. The Python interpreter is a program that reads and executes Python code. It takes your written Python instructions and translates them into actions that your computer can understand and perform. So in a compiled language, the code is compiled first into the instructions that your computer can understand and perform. In an interpreted language, the code is interpreted at runtime. So in a language like C#, when the code is compiled, any type mismatches in code will be flagged at this time. So you won't be able to deploy your code until the relevant data type related errors are resolved. In Python, an interpreted language, the data types are determined based on the values assigned to the relevant variables at runtime. It is important to note that this makes Python code prone to data type related runtime errors. So this can be seen as a disadvantage of a dynamically typed language like Python. So how does the Python interpreter work? The Python interpreter firstly reads your code. The interpreter reads the Python script or interactive commands. The Python interpreter then translates your code. It converts the code into an intermediate form, bytecode. The Python interpreter then executes your code. It runs the translated bytecode using the Python virtual machine, PVM. So let's briefly discuss variable naming conventions in Python. In Python, variable naming follows these conventions. Use descriptive names. Variable names should be meaningful. For example, use total_price for your variable name instead of just TP. Start with a letter or underscore. Names must begin with a letter, so lowercase a to z, or uppercase A to Z, or an underscore, but not a number. Use only letters, numbers, and underscores. Special characters like @ the dollar symbol, or percentage symbol are not allowed. Variables in Python are case sensitive, so age, and age are different variables. Use snake case for multi-word names. Words should be separated by underscores. User underscore name, max underscore value. Avoid reserved keywords. Words like class, def, and import cannot be used as variable names. Reserved words are keywords used by the Python language itself. Use leading underscores for private variables. Underscore private underscore var is a convention for internal use. Don't worry too much about this for now. We'll discuss this further when we look at classes in Python. Use double leading underscores for name mangling in classes. Underscore underscore name helps avoid name conflicts in subclasses. Once again, this is something we'll discuss further when we look at classes in Python later on in the course. Constants are written in uppercase. For example, pi equals 3.14159. It is important to note that following these conventions improves code readability and maintainability. If you feel like you're gaining value, please hit that like button and please consider subscribing to the channel if you haven't yet subscribed. And please don't forget to ring the bell. Please share this video with anyone you feel may benefit from its content. If you'd like to thank me by buying me a coffee, you can do that at my Buy Me a Coffee webpage at this URL. It will of course be greatly appreciated. If you have any questions about what you are learning in this course, please feel free to drop me a comment in the comments section. I will respond as soon as possible. Having said that, all comments are welcome. Your insights are always greatly appreciated. If you'd like to follow me on X, my username is @GavinLonDigital. Right, let's get back to learning Python. Instead of uname here, a better convention would be user underscore name, which is snake case. And we just get rid of this here. And print user underscore name to the console screen. So snake case is where we separate two distinct words within our variable names by and underscore like this. And of course our variable names should be descriptive. So user underscore name equals Bob. It's describing the data that will be stored within the variable. So let's discuss the string data type in Python. A string is a series of characters. What do I mean by character in Python? Unlike in C#, there is no char data type in Python. In C#, you can store one character in a variable defined as the char data type. So if we go to our C# code here, let's just get rid of that. We could actually define a character using the char data type like this. Let's call that C, and then when we assign a value to it, you can assign just one character like this. For example, V, or it can be any character. It could be a special character. It could be an @ symbol, for example, and that's also a char. It could be a number. You can't, of course, use this number in mathematical operations. It would have to be defined as a numeric data type if you wanted to use the particular value in a mathematical operation. But you can store a literal character within a variable defined as char in C#. So if we clear the screen, we go .NET run. It prints 1 to the screen. So whereas in C# you do have the notion of a char data type, in Python there's the notion of a character or series of characters stored within a string. You could just assign one character like this to a string. So you'd go C equals to 1, or so it could be a special character, it can be a number, but it can also be a string of characters. But there's no notion of char, which just represents storing one particular character in Python. So a string is just a series of characters in Python, basically. And that's your string. And you can print it. Of course, we've already done this. You can print it to the console screen. And that's your string being printed out to the console screen. It's a series of characters, H, E, L, L, O in this particular case, or B, O, B in this particular case, or in this case, it's just a number 1 or 1098. That can also be a string. Great. So a character can be an alpha or numeric character. It can also be a punctuation mark, for example, or a special symbol like a dollar symbol or a percentage symbol. So you can store a number within a string, but a number stored within a string does not have a numeric value, i.e. you won't be able to use a number stored as a string within a mathematical operation. So let's try that. Let's go C equals to 1098, and let's go D equals to 5, for example, like this. Now, if you tried to do a mathematical operation like C plus D, for example, it's not going to add 5 to 1098 because neither of these are numeric values. So these are representing a string of characters, if you like, a series of characters. They're not representing numerical values because they are stored in their relevant variables as strings. So when we run this code, the 5 is literally concatenated to the 1098 string. We'll discuss concatenation in an upcoming video, but it's important to note that these are strings, and that's a fundamental difference between a string and a number in Python, because as it stands, these numbers are just a series of characters. They are not numeric values. But if we removed their quotation marks, they would be numeric values because they are now integers. So now we have 2 integers here, and we can perform a mathematical operation. And you can see the expected result is 1103, which is 5 plus 1098. But when we wrap them in even single quotes, remember a string can be wrapped in either double quotes or single quotes. It can actually be wrapped in triple quotes, but we won't discuss that in this video. Now when we run our code, main.py, the 5 is simply concatenated. The literal character of 5 stored as a string is concatenated to the string of characters 1098, and we get this result, 10985. Another data type in Python is the integer, which is used for storing whole numbers. An example of an integer is the number of people enrolled in a particular course. You can't, for example, have 21.5 people enrolled in a course. Each human being enrolled in the course represents a whole number of 1. So you can, for example, have 21 people enrolled in a course, but it doesn't make sense to have 21.5 people enrolled in a course. So let's assign the value of 21 to a variable named number enrolled. So let's go number enrolled, and you can see I'm using the snake case naming convention for our variable equals to 21 like this. And of course we can use an F string to print out a narrative that 21 students are currently enrolled in our course. And within the curly braces we can include our integer value like this, but we must precede the first quotation mark with lowercase f like this. So we are using an F string in Python. Whoops, and we've got a curly bracket there that we don't want. And now if we run this, it prints our narrative to the screen where we can include the value stored in our integer variable within the literal string that represents our narrative. And we can use an F string to print our narrative to the screen, which will include the value stored within the number underscore enrolled variable. Excellent. So we have used an F string in this part of the course as well as in the previous part of the course. What exactly is an F string? An F string, formatted string literal, in Python is a way to embed expressions inside string literals using curly braces. So using an F string, you are able to perform expressions, functions, and formatting directly inside curly braces within your string literal. So the rule in code to create an F string is precede the string literal with a lowercase f, which stands for formatting, and then wrap the relevant expression, function, or formatting inside curly braces. So as mentioned, when discussing integers in Python, you can't have a count of 21.5 people enrolled in a course. This doesn't make sense. But you could, for example, have a count of 21.5 slices of pizza. So in Python, we can use the float data type to store values that have fractal parts, like, for example, 21.5. So let's rename this variable here to pizza slices. And now we can add a point mark like this, a full stop, to represent that we're about to include a fractal part to this numeric value. So 21.5, 21.5, like this. And now let's change our narrative to suit our numeric value of pizza slices. And we can change our F string to reflect an appropriate narrative. I ate 21 slices of pizza and feel really bloated. Like this. And let's run our code. I ate 21.5 slices of pizza and feel really bloated. So this is how we create a float in Python. A float is used to store numbers that have a fractal part to them. So this could be 21.8, for example. But let's include 21 or 21.25, 25, like that. We go pi main.pi, and we can output our interpolated string. This is also can be called interpolated, an interpolated string, where we're including a variable within a string literal, directly within the string literal that we're printing to the screen. So this string has been interpolated. Just escape out of that there, clear our screen. We've eaten 21¼ slices of pizza here. So this is a float in Python. And as always, the variable's data type is just determined at runtime by the Python interpreter by the actual value that's assigned to it. So you don't, like you would in C#, declare a float. You don't have to do this. Python will infer the data type by the value that's been assigned to it. So if it was just 21, that would be, if that was just 21, that would be considered an integer because it's a whole number. But 21.5 or 25, 21², that's a float in Python. Whereas in C#, a float would need to be defined explicitly like this. And in fact, when assigning a float in C#, you'd have to include the F suffix like that within it. Because there are strict typing rules in C#. 1.25. Okay. So we've discussed strings, integers, and floats in Python, and we've used them within an F string. We've used each of these data types within an F string to print a narrative out to the screen. The one data type that we haven't yet discussed is the Boolean data type. So what if we only want to store a value that is either true or false in a variable? We have the Boolean type for this purpose. So let's assign true to a variable called isEnrolled. So this represents whether a particular student is enrolled in a particular course. And let's assign true to isEnrolled. And then we can also include our Boolean value within an interpolated string or an F string. So I'm going to change this narrative to it is, and then isEnrolled, that I have enrolled. So it is true that I've enrolled should be printed to the screen. Let's prove this. Let's run our code. It is true that I've enrolled. Okay, so that's worked. So now we could also set that to false. So a Boolean variable can only be true or false in Python. And also note that unlike in C#, where the F in false would be in lowercase, in Python it's in uppercase, and the same goes for true. In Python, the T in true needs to be in uppercase, whereas in C# it's in lowercase if you're using a Boolean literal. Okay, let's see what happens when we set it to false, and you can guess pretty much what's going to happen. It is false that I've enrolled. Okay, that's pretty obvious. But note that with a Boolean value, you typically wouldn't use it directly within a string literal like this, within an interpolated string. We'd typically use Booleans for decision-making code, as it were. For example, using a Boolean variable within an if statement. We'll discuss if statements a bit later in the course in more detail. But let me demonstrate the use of an if statement. So let's say if is enrolled equals true, and of course the T must be capitalized in Python here. Then we include a colon like this for our if statement. This is just how if statements work within Python. And then we're just going to output a narrative for the case where isEnrolled equals to true. So I'm just going to set this to true here. and say that I have it, or let's rather say you have enrolled in the course, like this. Okay, and let's run that code like this. You have enrolled in the course, so that is true. So if this was set to false, nothing will actually be printed to the screen. Let's prove that. And of course, nothing is printed to the screen in the case where is enrolled has been set to false. So we could include an else part within our if statement to account for when the variable's value is false, like this. And then we can print an appropriate narrative to our screen. So let's say you have not enrolled in the course in the case where is enrolled has been set to false. And let's run our code. You have not enrolled in the course, so that proves that that is all working. Now, you can make this code slightly more readable, although that is fairly readable, but you can shorten the code by just removing this in the case of a Boolean. So it actually reads better. If is enrolled, you have enrolled in the course. Else, you have not enrolled in the course. So by just omitting the double equals true, so this is valid Python code to check whether the is enrolled variable is true, but this is also valid Python code to do the same thing. So you can see that we can't use one equals for this purpose here, because one equals means assignment in Python. Double equals means you're evaluating a variable against a value, like this within an if statement. We're comparing one value to another using the double equals, and we use one equals to assign a value to a variable. Great. But we'll go into more detail with more comprehensive examples as the course progresses. As discussed, we'll look at if statements in much more detail in a later part of the course. So this has just been a basic introduction to variables and data types in Python. We'll look at how to perform mathematical operations using Python in the next part of the course. We'll then look at typecasting in Python and create more comprehensive code examples related to variables and data types. If you feel you have gained value, please hit the like button. And if you're not yet subscribed to the channel, please subscribe. And please don't forget to ring the bell. Please share this video with anyone you feel may benefit from its content. If you'd like to thank me by buying me a coffee, you can do that at my Buy Me a Coffee webpage at this URL. It will of course be greatly appreciated. If you have any questions about what you have just learned in the course, please feel free to leave your questions in the comments section. I will respond as soon as possible. Having said that, all comments are welcome. Your insights are always greatly appreciated. If you'd like to follow me on X, my username is @GavinLonDigital. I hope to see you soon. Thank you and take care.